this is Karthikeya Bansal and today I am going to explain you about the SSL protocol. SSL protocol stands for Secure Socket Layer Protocol. It basically provides security between the two entities. These two entities might be web browser and the web server, basically the client server structure. So how does it work? It works basically on three aspects, that are integrity. That is, the message which is sent by the sender should be received by the receiver in no altered form. That is, it should be received intact. Authentication. That is, both the sender and the receiver should be authenticated by our SSL layer. Confidentiality. That is, the data should not be accessed by any unauthorized access while it is being transferred. So where does this layer lies? The position of SSL is exactly between the application layer and the transfer layer. It, on the sender side, encrypts the data, adds header to it and sends it to the receiver, while on the receiver side it removes the header and decrypts it to receive the original message. This layer has basically four protocols, which include Handshake protocol, record protocol, alert protocol, Change-cipher, spec protocol. So without further ado, let's get into them. Out of these four protocols, Handshake protocol and the SSL record protocol are the backbone of our secure socket layer. So let's learn more about each one by one. SSL record protocol. SSL record protocol provides us with the integrity, that is, the message should be received in no changed form. The unaltered form is maintained throughout the transmission. And confidentiality, that is, the data should be accessed by only authorized users. The process begins with the layer receiving plain text from the application layer. Once this layer receives plain text from the application layer, it then uses any of the lossless algorithms to compress this data. This compressed data is further appended with the MAC, that is message authentication code, which is calculated and appended to this packet. Further, this packet is encrypted using any of the suitable algorithms. After all these steps, a record header, that is a specific header of our layer, is added. The process is completed as far as the SSL record protocol is concerned. The encryption done makes sure that the confidentiality of the data is maintained, while the MAC appended makes sure that the integrity of our data is maintained so that no unauthorized access is possible. Hence, both confidentiality and integrity is achieved. Change-cipher protocol. Though this protocol is not the backbone protocol, yet it helps the Handshake protocol to get completed. Change-cipher protocol consists of single message which is 1 byte in length and can have only one value. This protocol's purpose is to cause the pending state to be copied into current state. Unless Handshake protocol is completed, the SSL record output is kept in pending state. After the completion, the pending state is converted into the current state. This causes the change in byte. This change in byte keeps a track of this record and hence helps in completion of the protocol. Handshake protocol. Handshake protocol is a very important protocol for SSL. It is used to establish session. This protocol allows client and server to authenticate each other by sending a series of messages. Thus, from establishing a secure connection to authenticate each other, Handshake protocol takes care of all these things. The process is done in four phases. Let us go through them one by one. Phase 1. In phase 1, both client and server send hello packets to each other. It can be also called as establishing a connection phase. SSL version, session ID, list of cipher suites, list of compression methods, and so on are exchanged for security purpose in this step. Phase 2. This phase is also known as server authentication and key exchange phase. In this phase, the client is silent. The silence of the client is because it first needs to verify that whether the receiver is legal or not. In the step, server provides the certificate for the confirmation. It also sends the required keys. The sender ends this phase by sending the server hello end packet. Now we move to the phase 3. This phase is client authentication and key exchange. In this phase, client replies to the server by sending his certificate and client exchange. Here we see that the server has already been verified by the SSL. So now it's the duty of the client to do the same. After this phase, the client is also verified and it also sends hello end packet. Phase 4. Phase 4 is the finalizing phase. Change-cipher suit also occurs in this phase. Client sends the cipher specification, current status and such important details. After this procedure, the client is done. Server also sends the same so that they both are on the same page, that is, they have the same algorithms of same versions. Hence, after this phase, the authentication is completed with a secure established connection. Alert protocol. The role of this protocol comes into play when some sort of issue arises in the transfer. This protocol is used to convey the SSL related alerts to its peer entity. That is, if any of the entities detects an error, then it sends it to other. Each message in this protocol contains 2 bytes. First byte containing the level and the second byte containing the alert. For level and alert, let's learn a bit more. When an error arises, the level might contain 2 values. It could be either a warning or fatal. When the level is warning, there is not much effect on the execution. But if the level is fatal, it immediately terminates the connection and restricts any further progression of the process. Now we come to the alert bit. The alert bit contains the code specific to the alert. These alerts are generated and can be of many forms. For example, the close notify alert. The close notify alert says that there is no more message sender. That is, the sender has either disconnected or at the moment is unable to send any of the messages. Next comes the unexpected message. Unexpected message says that it has received something from the sender which was not expected and hence it's wrong. It should be taken care of. The next is bad record MAC. Bad record MAC says that the MAC calculated and appended is wrong. That is, for the sender and the receiver it is not matching. Here, while referring to the MAC, we are referring to the message authentication code which was calculated and appended earlier in the SSL record protocol. The last one is bad certificate. It says that the certificate received is corrupted or the certificate has expired. That is, the certificate which the sender has sent is not the verified one and hence the connection should be stopped. Here we saw that how the different layers in SSL behave. SSL was originally created by Netscape. It is designed to use a TCP protocol to provide reliable end-to-end secure service. It is dynamic in nature and can be tailored to the specific needs of the given application. SSL is in itself a two-layered protocol, hence making the connection between the sender and the receiver more secure. So that was all about the SSL layer and its protocol. Thank you and thanks for watching.